discussions of the past year questions. This video, we shall take a look at the further maths paper 1, October, November 2023, paper 11. Let's take a look at the first questions. Series. Number 1A. By considering the r plus 1 square minus r square, use the method of differences to prove this formula. So what you need to do here is that just follow the instruction, r plus 1 square minus r square. If you expand and simplify it, you will have r square plus 2r plus 1 minus r square. This one can cancel off. Then it will equal to the 2r plus 1. So from here, since they mention method of differences, so when you use method of differences, there must be a minus in between. Okay, so we will use this left-hand side to do the method of differences. So this will be the r plus 1 square minus the r square. Then your right-hand side also must put in the sigma symbol to r plus 1. Okay, so this is what you need to do at the very beginning. Then after that, the left-hand side is method of differences. Just substitute 1, 2, 3, 4, 5 inside. So if you put 1 inside, when r equal to 1, you will get 2 square minus a 1 square. Plus when you put r equal to 2, you get a 3 square minus a 2 square. When you have r equals to 3, you have a 4 square minus a 3 square. Then the pattern will follow until you have the n square minus the n minus 1 square. Then the last one will be n plus 1 square minus the n square. Okay, this is your left-hand side. So your right-hand side, just apply the property of the series. Just like that. Okay. So from here, this whole thing over here, you can cancel it off. You can see that the 2 square, 3 square, all can be cancelled off. They follow in this pattern. So at the end, you're left with only n plus 1 square minus a 1 square equal to the 2 sum of the r plus n. Okay. So 2 multiplied by the sigma r is equal to the n square plus 2n minus plus 1 minus 1 minus n. You bring this n, go to the other side. Then you get a minus n. So after that, you simplify them. You will get the sum of the r. It will be equal to the half of n square plus n. Factorize it. Shown. So this will be the answer for the number 1A, just like that. Okay. Then now we move on to the part B. So part B, they giving you the relationship over here. Sum of the r plus a is equal to n. We want to know what is the value of. We want to know the a in terms of n. Okay. So what you need to do is to apply the property of a series. Then you will get this. So a is a constant. Since the a is a constant, so we will have, this one is actually from the part A just now. From the part A, we have this result. You will have half n, n plus 1, done. Then this part, it will be an. So you're looking for a, right? So you can see that the n, all the n can be cancelled off. So your a will be 1 minus the half of n plus 1. Then you can get this one as a half of 1 minus n. That will be your a. Done. That will be the answer for the number 1B. Okay, so we will take a look at number 2 in a short while. Welcome to the discussions of the past year question. This video, we shall take a look at question number 13, 2021, October, November, paper 21, question number 1. Find the Maclaurin series for the EX multiplied by tangent X from the first principle up to and including the terms in X squared. Okay, so that means we need to do until the second derivative. So as usual, first of all, we just let the function fx call the e power x tangent x. Then we differentiate it for the first time. Product rule, keep the left, differentiate the right, plus keep the right, differentiate the left. So usually we will factorize it out. And this is what we get. Now after that, you differentiate it for second time. Differentiate it for second time. Keep the left, differentiate the right. And not to forget about keep the right, differentiate the left. So you keep the right, differentiate the left. Okay, so this is what you have. Then now you just need to replace x equal to 0 in each and every one of them here. So this one you will get 0, this one you will get 1, this one you will get 2. Okay, so therefore your function will be the f0 plus the f prime 0x plus the f double prime 0 x squared over 2 factorial plus a dot dot dot. Then you can just write an approximation. Your fx is e power x tangent x approximately equals to the x plus the x squared. Just like that. Okay. Done for these questions. I'll stop the video here. Okay, now we take a look at question number 3. The quadratic equations x power 4 plus bx cubed plus cx squared plus dx minus 2 equal to 0 has roots of alpha, beta, gamma, delta. It is given that they are having this relationship. So the part A, they want you to find the values of B, C, and D. So from here, part A, to find B is actually very straightforward. We just know that the relationship of alpha plus beta plus gamma plus delta is equal to negative B. So therefore, your B is a negative 3. So we have found the B. Then for the alpha square plus the beta square plus the gamma square plus the delta square is actually equal to alpha plus beta plus gamma plus delta minus the 2 of the alpha beta, alpha gamma plus alpha delta plus the beta gamma plus the beta delta plus the gamma delta. Okay, so we have this relationship. So you can actually straight away write down 5 is equals to the negative 3 square minus the 2c. So from here, we can get the c as the 2. Okay, so we have found the c as well. Now for the d, to find the d, first of all, we write like this, x power 4 plus b is a negative 3. Then the c is a 2x squared, and the dx, you do not know the d, minus 2 equal to 0. So what I'm going to do is I'm going to divide everyone by x to the power of 4. I get this. Okay. Then I bring it over here like this. Make it become 2, positive 2 multiplied by 1 over x power 4. Then minus the d of 1 over x cubed, then minus the 2 of 1 over x squared, and then plus the 3 over x, then minus a 1 equal to 0. Divide everyone by 2, then you get d over 2. This is what you get. Okay, so that means now all the root over here will be in the form of 1 over alpha, 1 over beta, 1 over gamma, and 1 over delta. So the root of this equation will be in the form of this. But you're looking, the information given in the note in the question is 1 over alpha. This is the information given. Is 1 is equal to 6. So which means the 1 over alpha plus 1 over beta plus 1 over gamma plus 1 over delta is equals to d over 2. Okay, that will be 6 equal to d over 2. Therefore, your d is a 12. Just like that, done. So this will be the answer for the part A. Now we move to the part B. Given also that alpha cube plus beta cube plus gamma cube plus delta cube equal to negative 27, now we want to find alpha power 4 plus beta power 4 plus gamma power 4 plus delta power 4. So this is actually kind of straightforward. So first of all, we just let Sn equals to alpha power n plus beta power n plus gamma power n plus delta power n. So we already have S1 is equals to 3. This is S1. This is S2. Okay, so S1 equal to 3, S2 equal to 5. Now with the information given here, we have S3 equals to the negative 27. So we take our equation here. This equation, make it become 3x cubed minus 2x squared. 3x cubed minus 2x squared minus a 12x plus 2. Then you are having S4 equals to the 3S3 minus a 2S2 minus a 12S1 plus the 2S0. Oh, by the way, S0 is equal to 4. So your S4, this is your S4. Okay, this is your S4. So therefore, alpha power 4 plus beta power 4 plus gamma power 4 plus the delta power 4 is equals to the 3 multiplied by negative 27 minus a 2 times 5 minus a 12 times 3 plus the 2 times 4. So we just need to use our calculator. Negative 81 minus 10 minus a 36 plus 8. You get negative 119. Done. This will be the answer for the part B. Okay. So move on will be question number 7. Take a look at question number 4. Vector. So the line L1 and L2 have equations given as following here. Respectively, find the shortest distance between L1 and L2. So over here, actually, you can just apply the formula directly. Okay. But over here, in order to get the shortest distance between two lines over here, so first of all, we need to check they are not parallel. Okay, so they are not parallel, then they must be skew. Okay, so over here, what you need to do is to find the cross product. We want to find the normal vector of the two lines. Okay, so because the lines are skew like this, so we need to find the n. We need to find the n. Okay, so in order to find the n, we need to, this is the distance. In order to find the n, we need to have a skew line first. We need to have a normal vector. So to get a normal vector, we must do the cross product. So it will be negative 4, 3, 5 cross with the 2i negative 3j k. So if you do the cross product, then you will get the 18i plus the 14j plus the 6k. So you can see that all of them are the even number. You can factorize the 2 out. Then I will just get my normal as 973. Okay. Then after that, I will just let this position vector call the OA, negative 2, negative 3, negative 5, and I let this position vector call OB, 2, negative 2, 3, okay, then I find the AB. So if I find the AB, then just take B minus A, you get a 4, 1, and then 8. So you get a 4, 1, 8, okay? So in order to get the shorter distance, so actually the formula will be AB dot product with the n divided by the magnitude of the n. Okay, so this is the formula. However, maybe we can just briefly explain how to get this formula. So we can actually, we have a skew line over here. So this is the A, this is a B. So we just connect them together, then we get an AB. And this is the shorter, this is a 90 degree. This is the shorter distance that we're looking for. So what we need to do is we need to have a theta here. So we have a right angle. You can see that if you put it sideways like this. So this is the A, this is the D, this is the B. In order to get over here, AB, BA, doesn't matter because we just want to find the magnitude. Okay, so this one is the, okay, maybe we can put it like this, the arrow, AB, like this. Okay, so you can see that this is the theta. Then the distance is actually magnitude of AB cos theta. And in order to get the magnitude of AB cos theta, that means D is equal to the magnitude AB cos theta. So this is supposed to be the formula. Then just put n here, divided by the magnitude n. Cancel it, you still get back the same thing, but I don't need to cancel it. So according to the formula, the numerator is actually the dot product of the vector AB dot n. So this is how you get the result. This is how you get the formula. But in exam, we are allowed to memorize this result directly. So there's no need for you to show. No need for you to show. So let's just don't waste our time on proving this. So in exam, no need to prove all this. Just direct apply the result or the formula will do. Okay, so this one no need. So now we just need to write D is equals to the AB dot product with the n, but you put modulus, then the divided by the magnitude of n. Okay, just like that. So what you need to do now, just to write down magnitude, the modulus. So what is your n? N just now was a 973. What is your AB? AB is a 418. So this one magnitude will be 9 square plus the 7 square plus the 3 square. Expand simplify, you will get 36 plus 7 plus 24 modulus divided by square root of 9139. Okay, so if you simplify further, you will get this is the answer. You can give me decimal as well. Okay, so in the mark scheme, they actually accept both, either the exact value or the mark scheme. So over here, I give both. You can decide yourself you want to leave the answer in the exact value form or the decimal form. So this will be the answer for the part A. So now we move on. Part B. The plane pi contains L1 and the point with the position vector of negative I, negative j, minus 3j, minus 4k. So find an equation of pi, giving your answer in the Cartesian form. So what you need to do that, okay, we can just try to imagine that we have a pi over here. This is a plane pi, and inside this plane contain L1. And also there's another point here called this point. The point over here is -1, -3, -4. And if you go to the line L1 just now, this is the L1. So L1 contain -3, -2, -3, -5. So this L1 contain this -2, -3, -5. Okay. So just now I call this one OA already. Okay, just now I have a OA equals to the -2, -3, -5. Now we already have OB. So this point I call point C. This point I call point C. OC is a -1, -3, -4. Okay. So what I need to do now is to find the AC. So the AC will be taking the C minus A. You get 1, 0, 1. You get 1, 0, 1. Okay. So if you connect them together, you'll get something like that. So in order to get the normal vector, you just need to cross product between the AC, the normal, just take the AC, 1, 0, 1, cross with the directional vector of the L1. The directional vector of L1 is -4, 3, 5, -4, 3, 5. So just calculate, you get -3i. Then this one is the 5 plus 4, 9. 5 plus 4, 9. So it's a -9j. Then k will be a 3k. And if you factorize the 3 out, you get -1, -3, and 1. Okay, that will be your normal vector. So means my normal will be -1, -3, 1. So equations of pi, it will be the normal vector here, dot with the x, y, z, equal to the normal vector, dot with the fixed point. The fixed point, you can choose OA, you can choose OC, that is up to you. For this case, I choose OA. Then I get -x minus 3y plus a z equals to a 2 plus 9 minus 5. Then you get x plus 3y minus z equals to the -6. Done. That will be the answer for the question number 4B. Okay, number 4B done. Okay, now we take a look at question number 5. Matrix. Let K be a constant. The matrices A, B, and C are given as following here. Given that A is singular. So from here, when the A is singular, it means that the determinant of A will be a 0. Okay, so given A is singular, that gives you that the determinant of the A will be 0. So to find the determinant A, just put 1, 2, 3, K, 1, 2, 3, 3, 5, 0. Then you will get 1, 5 minus 6 minus a K of 10 minus 9 plus the 3 of 4 minus 3 equal to 0. Expand, simplify, you will get the K is equal to 2. So the very first thing is to find the K. So once you find the K, then the CAB will be the matrix of the C. This is the matrix C. A is 1, 2, 3, 2, 1, 2, 3, 3, 5. Then the B is 0, negative 1, 0, negative 2, 3, 0. So just need to multiply these three. But we cannot multiply the three matrices at the same time. So you can choose either the first two, multiply first, and then after that multiply by the third one. Or you can choose the last two, multiply first, and then multiply the first one later. So for this case, I will choose to multiply the first two first. So the first two, if I multiply it, carefully, so you can try to do it yourself. I will straight away apply to give you the sum, the product for the first two matrices. This is what I get. Then multiply by the third matrix, matrix B. So at the end, you will get the answer 3, negative 9, negative 7, 3. So shown. Done for this part A. Okay. Then part B, they are asking you to find the invariant lines that go through the origin that transform XY plane represented by the CAB. So this one actually quite routine. Just do like this. This must be the matrix CAB. CAB, just now the matrix is a 3, negative 9, negative 7, and the 3. So this will be letting it as a X, MX. This one will be uppercase X, M uppercase X. Just like that. Then expand, you get 3X plus minus 7MX. Negative 9X plus the 3MX is equal to the X and then MX. So if you compare them like this, then this one is a negative 9 plus 3M. Call this equation 1, call this equation 2, and you just do a division. Take the 1 divide 2 or the 2 divide 1. Then you will get this relationship. Do the cross product. Then you will form a quadratic equation. 7M squared. This one can cancel. Is equal to 9. That means my M is equal to plus minus 3 over 7. So therefore, the invariant line be Y equals to the 3 over 7X and Y equal to negative 3 over 7X. So these are the two invariant lines that we need to find. Just like that. Done for the part B. Move on. Question C. The matrix DEF, the matrices DEF represent geometrical transformation in the XY plane, where the D is an enlargement enlargement center at the origin. Okay. Then E represent the stretch parallel to the x-axis. So when it's a stretch, I need to know the scale factor. This one also enlargement, we also need to know the scale factor. So this one, I let it have the scale factor called K. This one, I have a scale factor, maybe I let the scale factor called alpha. F represented by the reflection. This one only scale factor. Okay. So this one, you need to memorize all the corresponding matrices for each transformation. So for this case, we just let our D, for the enlargement, it will be K0, 0K. For the E, since it's the stretch, so it will be alpha 0, 0, 1. This one all just memorize the matrices that represent each of the transformation only. So the reflections y equal to x, it will be 0, 1, 1, 0. So this is what we have. Then the questions say that the CAB equal to D minus 9EF. So which means CAB, we already have CAB from the part A just now is a 3, negative 9, negative 7, and 3. Then the D is this, minus a 9 EF. So the right hand side, we need to do something. We need to do the matrix algebra here. So this one just multiply and combine together. You're supposed to get K negative 9, negative 9 alpha, and K. So by comparison, your K is a 3, your negative 9 alpha is a negative 7, then your alpha is a 7 over 9. Therefore, we have found the D. D is a 3003. E will be the 7 over 9, 001, and F, we already have F, 0110. Just like that, done. This will be the matrix for the D, E, and F. Just like that. So move on. We have question number 6. Okay, now question number 6. A shows that the curve with the Cartesian equation has the polar equation R equal to cos theta. So what we need to do now is that at first, x minus half square plus the y square equal to 1 over 4. We just expand them. So you can see that the 1 over 4 can be cancelled off. Rearrange everything, let the x squared plus y squared is equals to the x. And if you convert to the polar form, you know x squared plus y squared must be r squared. X must be r cos theta. So the r cannot be 0 over here. We will ignore the r equal to 0 over here. So the r is equal to cos theta. Shown. Okay. Then part B. The curve C1 and C2 have polar equation. This is the curve C1. This is the C2. Represented by 0 to half pi. The curve C1 and C2 intersect at the pole. Pole means 0, 0. And another point P. Find the coordinates of P. So what we need to do, just need to solve the simultaneous equation. Our R equal to cos theta is equation 1. Our R equal to sine 2 theta is equation 2. So 1 equal to 2. In order to find the intersection, that means you have cos theta equal to the sine 2 theta. So this one is a 2 sine theta cos theta. So at the end, you have a cos theta 1 minus 2 sine theta. Then you have a cos theta equal to 0 and sine theta equal to a half. For the cos theta equal to 0, you just ignore it. Because when the cos theta equal to 0, your r is a 0. And if your r is a 0, it will be the pole. So we do not want the answer to be the pole. We want another point P, so we will ignore it. That is the reason. But usually in exam, just write ignore will do. So now from here, our theta is equals to the pi over 6. That is the only one answer because your domain is 0 to 2 pi, only first quadrant. So therefore, your P will be R. What is R? Oh, I forgot to find the R. When the theta equal to pi over 6, what is your cos? So theta equal to pi over 6, your R is equal to cos pi over 6 is a sec 3 over 2. So therefore, the P is sec 3 over 2 and pi over 6. That will be the coordinate of a P, polar coordinate of P. Done for the part B. Then C, we want to sketch the diagram. So over here, I only draw freehand. So my drawing may not be so nice compared to using the proper geometry set. Compass, you just use protractor and compass to draw it. So you can draw a better, just to have a better diagram. So over here, I just a sketch. So my drawing may not be nice, but hopefully you can understand what is the answer. What does a graph look like? So over here, we will, I need to have a proper scale. So you can see that actually this one is, this equation just now was a circle. This one is a circle. Center at half 0 with a radius of half. Okay, so like this is a half. This is a 1. So it's supposed to be a circle. Supposed to be a circle like this, but because the domain given is only 0 to pi, the domain given is only 0 to half pi. So the one, you can only have semicircle. So the circle will look like this. Okay, again, I draw in freehand. So the circle, it will not be perfect. It will not be nice. Something like that. Okay. Then after that, we have this, what do you call this? This one is a C1. This one is a C1. Then we want to have C2. Maybe C1. Put it like this. Then to draw C2, C2 is R equal to the sine 2 theta. So for sine 2 theta, since our theta is 0 to pi over 2, so also your answer need to substitute in the value one by one. So over here, for the R equal to the sine 2 theta, if you are not so confirmed with the graph, so usually we'll suggest you to draw a table. Theta from 0 until pi over 2, maybe in between, I will assume that it will pass through pi over 4. Then I find the R. This one will give you 0. This one, pi over 4, will give you a 1. This one will give you a 0. Okay, so pi over 4 is somewhere here. This is the pi over 4, 45 degree. Okay, 45 degree. So at first is 0, at last is still 0, but in pi over 4, you get a 1, somewhere like this. So your answer will be, your graph will be like this. Maybe I use a different color. It will be like this. And you can see that there's a one intersection point and one intersection point here. This intersection point is a P. This intersection point is a pole. Okay, so the diagram will be like this. So in order to get the perfect graph, you just refer to the mark scheme. Mark scheme will show you the perfect graph. So over here, I just show you the idea of how to draw it. So this graph is called C2. Okay, just like that. And then maybe you show that this one is a pi over 4. Easier. Okay, so that will be the answer for the part C. Then now, D, the region R enclosed by the C1 and C2 include the line OP. Find in exact form the area of R. So we are looking for this area. Actually, we're looking for this area. So for this area, actually, what you need to do is that this area include the line OP. This is the line OP. So this part of the area is actually only for the C2. And this part of the area is only belong to the circle. So we need to do the area separately. The area have to solve separately. So I don't want to make my diagram messy over here. I just write like this. Okay, so now for the area, if you refer to the diagram, area we have two parts. The first part is the C2. The first part is the C2. That means you are starting from 0 until pi over 6. Until pi over 6. Then R square. So your R square will be C2 will be sine 2 theta square d theta. Then half of pi over 6 until pi over 2. Pi over 6 until pi over 2. Right? So at first, this area is actually from 0 to pi over 6. And then after that, this area, it will be from pi over 6 until pi over 2. So you have two separate area, but you join together. So this one, it will belong to the C1. C1, it will be cos theta square d theta. Okay, so this is what you need to write down the formula at the very first line. Okay, so now what you need to do now is just to expand and simplify. Think about how to integrate them. So for the sine square, you need to go back to the basic of the integration. How do you integrate sine square? Just apply the double angle formula. You get 1 minus the cos 4 theta divided by 2 d theta. Then how do you integrate cos square? Also double angle formula. So this one will be 1 plus cos 2 theta over 2 d theta. So now, 1 by 1 integrate theta minus the 1 over 8 sine 4 theta from 0 to pi over 6. This one is a half theta plus the 1 over 4 sine 2 theta from pi over 6 to pi over 2. Okay, so this is what you are having. Then substitute the pi over 6 inside, you get pi over 12 minus the 1 over 8 of sine 2 pi over 3 minus a 0. This one, it will be pi over 4 plus the 0 minus the pi over 12 plus 1 over 4 of sine pi over 3. Okay. So now you simplify them. You get half of the pi over 12 minus the sine 2 pi over 3 is a sine 3 over 2. So minus the sine 3 over 60 plus the, I factorize the half and the half out. I factorize the half and the half out. So I will get pi over 4 here minus a pi over 12, then minus the sine 3 over 2, sine 3 over 4, sine 3 over 8. Okay. So you can see that the pi over 12 and pi over 12 can be cancelled off. Okay. Then the remaining one, just simplify. You get pi over 8 minus a 3 sine 3 over 32. Done. That will be the answer for the part. Question number 5D. Just like that. Done. Move on will be question number 7. Okay, now we take a look at question number 7. The curve C has the equations y equal to fx, where the fx is equal to the x squared plus 2 over the x squared minus x minus 2. Find the equations of the asymptotes of C. So for these questions, we have the vertical asymptote will be just letting your denominator equal to 0, factorize it. Then you will have the vertical asymptote as x negative 2 x is equal to -1 and x equal to 2. Then for the horizontal asymptote, we just need to let the y is equal to the limit to x go to infinity of the fx. That will be the limit of x approaching to infinity of x squared plus 2 over the x squared minus x minus 2. You will get the answer is 1. So for this case, you are having the answer for the vertical asymptote have 2 and horizontal asymptote have 1. Then after that, we want to find the coordinate of any stationary point, giving your answer correct to 1 decimal place. Okay, so they want the answer in the 1 decimal place. What you need to do now is to differentiate f prime, keep the bottom, differentiate the top, plus a minus, keep the top, differentiate the bottom, divided by the bottom square. To find stationary point, you need to let your f prime equal to 0, which means that you're just focusing on your numerator, making your numerator equal to 0. Finding the x from here, can already. So we just need to expand. You have a 2x cubed minus a 2x squared minus a 4x minus the 2x cubed minus the x squared plus the 4x minus the 2 equal to 0. Cancel the 2x cubed. Simplify. You get a negative x squared minus a x plus a 2 equal to 0. Can just use a calculator. So if you use a calculator, get the answer, you will get the answer x is equals to the 0.243. Then another one is x is equals to negative 8.243. But the questions want the answer in 1 decimal place. So you can just give me the answer 0.2. But never mind first, because I want to find the y. In order to find the y, I cannot use 1 decimal place of the answer of x to find the y. I need to use more decimal so that I can get a more accurate value for the y. So I use this to find the y. And if I use a more accurate value to find the y, my y over here will be a negative 0.943. My y over here will be a positive 0.943. Then therefore, my stationary point now I'm writing the answer in the form of 1 decimal place. 0.2, negative 0.9, and negative 0.8, 8.2, and 0.9. Now I only write the answer in 1 decimal place. Done for this part B. Now we move on. We have a part C. Sketch C, stating the coordinates of any intersections of the axis. So in order to find intersections of the axis, we just need to let x equal to 0. Your y will be the f0. It will be getting a negative 1. But when the fx equal to 0, actually you are having this. That is no solution, no real solution. So this one actually no need to show. I just mentioned over here, briefly go through. So you have only one intercept, which is the y-intercept. Okay, now ready to draw the graph. So in exam, try to make use of at least 70% of the space given and try to draw with a proper scale so that you can get the graph more accurate and show your graph in a better way. So this is a negative 1. This is a positive 1. This is a 1. This is a 2. This is a negative 1. This is a negative 2. So the negative 1 vertical, x equal to negative 1, you have a vertical asymptote. X equal to 2, you also have a vertical asymptote. Then y equal to 1, you're having a horizontal asymptote. Your maximum point is somewhere here, 0.2 and negative 0.9. Your minimum point will be negative, so you're somewhere here. Then you are having 0.9. Yeah. Okay. Then your graph will pass through this. So your graph will be like this. Okay. Your graph will be like this. Okay. So I think we need to show the features of the graph properly. Okay. Wait for a while. I think the negative 8.2, I will just write it somewhere like this. So that I can show the things more significantly. Okay. So this one, it will be a positive 0.9. But is over here, since it's not so nice because I'm not drawing following the scale. So it's better that we can just put it here, negative 8.2, 0.9. And this one is the 0.2, negative 0.9. Okay. So this will be the graph for the C. Okay. And now to sketch a D. D is a 1 over fx. To sketch a graph of 1 over fx, you need to understand that originally x and fx 1 over fx. Originally, we have a point negative 8.2 and 0.9. If you have 1 over fx, then you get 1.08, 1.06. Then originally you have a 0.2. Then if you, this one, it will be negative 0.9. This one will be negative 1.08. So just now, this one was minimum. This one was maximum. After reciprocal, it will become different. Okay. Then what else you need to take note? The intercept. The intercept is x equal to 0, fx is a 1. Fx is a negative 1. Reciprocal still negative 1. So the the y-intercept not the, still unchanged. Y-intercept still the same. Y-intercept still the same. Then what about the vertical asymptote? Vertical asymptote, when the x is a negative 1, you get infinity. But when it's a 1 over fx, you get 0. Same thing over here. This one is a vertical asymptote. This one also will get 0. Then your horizontal asymptote, your fx is a 1. Reciprocal is still get a 1. So these are the information given. So from this information given, actually, we can say that negative 1 and 2, your graph will pass through these 2 points. Okay? And negative 1, your graph will pass through this point as well. Then this is a 1. So I think I refer back to here. I use a different color. So actually this one will become 1 point. This one will become negative 0.82 and then positive 1.06. This one after reciprocal, it will become over here like this. It will become 0.2, negative 1.06. This one will become 0. So your graph actually will become this. Your graph actually will become this if you do the reciprocal. But the question didn't require you to sketch the original graph and the modified graph. at the same plane together. So we no need to show it over here. I just show to you so that now I'm going to plot it over here. So my graph is going to be like that. Okay, so this minimum point, it will become 0.2, negative 1.1. Maybe we make it become one decimal place. This one is negative 8.2. So you have negative 8.2, it will become positive 1.1. So that will be the graph for the D. Okay, then for E, for question E, to solve this question, I let them equal first. To let them equal, then I have a fx bracket square equal to 1. That means I have fx equal to positive negative 1. So fx equal to 1. I have x squared plus 2 over the x squared minus the x minus 2 equal to 1. Then I have x squared plus 2 equals to the x squared minus the x minus 2. Then I have x is equal to negative 4. Okay. Then when the fx is a negative 1, I have x squared plus 2 over the x squared minus x minus 2 equal to negative 1. Then I will have solve it, simplify. I have 2x squared minus x equal to 0. Factorize it. Then I have x equal to 0 and x equal to a half. Okay. So I borrow the graph over here. Remember just now I plot the graph like this. Just now remember I plot the graph like this. Okay. So you can see that it will intersect at 1. Okay, you remember that just now I plot the graph like this. You can see that they have intersections at 1. Okay. So you can see that they actually want the 1 over fx is smaller, less than, below they want the blue graph is below the black graph. So the blue graph below the black graph, then your answer will be only this portion, this portion, and this portion. Blue graph below the black graph. Blue graph is less than the black graph. Okay, so it's over here. Oops. This portion. That means we only want it to be this portion. We want it to be at this portion. Here, here, and here. That will be the answer. So it will be, the answer will be negative 4. Hey, wait, I calculate wrongly. Negative 4. X is a negative 4. Oh, okay. So this is a negative 4. Not I calculate wrongly. It's just that because my scale is doesn't correct. It's not so correct. So it looks a bit weird. So it's a negative 4. So it's negative 4 to negative 1. Okay. So therefore, from the graph, the inequality will be from negative 4 to negative 1. After that, 0 to half. And after that, x is greater than. Okay. Yeah. So you can see that the one that I highlight over here, these are the 3 parts. Okay, so done. That will be the answer for this question E. And no more. That will be the last question for this paper.